Hi, in this tutorial we're just going to go over reaction yields. So I'm going to try and do it systematically so we can get a nice structure to how you go about calculating the actual yield you should expect if you react two things together. So in this example I've got ethanol reacting with acetic acid to give ethyl acetate and water as a byproduct. So I want to know really, if I reacted 10 mils of ethanol with 10 mils of acetic acid, how many mils of ethyl acetate should I expect? But if you've seen Avogadro or the mole tutorials that I've done, you'll know that 10 mils of ethanol and 10 mils of acetic acid doesn't mean there are 10 lots of acetic acid molecules around which will react with an equal number of ethanol molecules. So if we look at these little molecule schematics I've done here, so if the red circle represents ethanol molecule floating around in space, and the blue one is acetic acid, when they react together they should form something similar like this, so they're both stuck together like that, and obviously we get water. So you can see that the mass, the overall mass of ethyl acetate, as this is called, is a slightly bigger than acetic acid or ethanol, but it's not actually as big as them both together because we lose water as well, so we lose part of them when we form this. So if we take, for example, 10 molecules of ethanol and we react them with 10 molecules of acetic acid, then we should expect, if I just grab this other bit, we should expect to get, if we get 100% yield, so let me just write that, so for a 100% reaction, that means every one of them has reacted with every one of them equally to give equal amounts from the starting materials to give equal amounts for the products. Then we get what's called 100% yield. Oops, there's an L in there. However, if, for example, these didn't all react as well together and we didn't get the full conversion, we would then be left with, say in this case, we've only got 6 of these reacting with 6 of these for some reason whatsoever, because it takes time to react things together. Then this would have to be calculated what our percentage yield would be, because to get all of them to react together to give us 100% yield would mean that we get 10 lots of molecules of this from 10 lots of molecules of that reacting with 10 molecules of that, but we don't, we get 6 in this case. So it would be, in simple mathematical terms, it would be 6 out of the possible 10 times 100 equals 60%. So that would be our yield. We'd have a 60% yield out of the possible 100%. Okay, so that's what we're talking about when we're talking about percentage yields. We're talking about how much we really would expect if it all went to completion. Okay, let's just get rid of that and that. So what we need to do now is actually go through the process. We're going to actually try and calculate what we should expect, and then try and work out what we do get, and then so we will know what we get because we'll be able to weigh it or measure its volume. If we know what mass we should have got, or we know what volume we should have got, then we'll be able to compare that with what the volume we get, and just like I did 6 over 10, then we'll be able to work out our percentage yield based on that. We should never get more than 100% because there's not enough materials to begin with. Okay, so let's move these out of the way for now. We might use them again later. Okay, now to do it systematically we need to work out how many molecules we've got in 10 mils. Now to do that we need to convert it to mass, because the mass of the atom will determine the actual mass of the formula that we've got. So ethanol, if I just write it out, CH3 CH2OH. Okay, so we have got 2 carbons, so the empirical formula will be C2, and we've got 6 hydrogens, got 3 there, plus 2, plus 1, H5O, because we've got an oxygen. So we will need to work out what the mass of all those atoms are. So the molar mass for ethanol, I've worked it out earlier. The molar mass for ethanol is 46.07 grams per mole, and that's because, without going into too much detail about how we work out the mass, because that's covered in another topic with Avogadro and the mole tutorials, I urge you to look at that. So basically it's 2 times 12, which is 24, plus 5 times 1, which is 5, plus 16 for oxygen, gives us 46.07. Okay, so that's how we get the mass. We base it on the mass of each element added together in the formula to give us the actual mass there. Okay, so that being said, you notice I put density here. Density is basically if we take a beaker, okay, and we take our atoms. Let's just pour these atoms in again. Now this might not be the best example. I'll just copy another set of those atoms. Oh, so they're not atoms, I keep calling them atoms. They're actually molecules of ethanol, they're supposed to be. Do another one. So what does density mean? Well, if you look there, the actual size of the molecule in a container, how it bonds with itself will affect like its overall volume per its mass per volume. It's how much you can pack in really in the solvent as a solvent. Density can be applied to solids as well, just as easily. The same principles really. But if we look at this beaker as an example, you see that the red molecules for ethanol here can all be tightly packed, and we've got a 10, 20, 30 in that tiny space there. Now if I did the same again for acetic acid here, just as an example, this is not necessarily true, the volume of acetic acid. We'll put that in there. So let's not call it acetic acid actually for now. Let's just call it some other molecule. You see we can't get as many in, and that means so these actually weighed the same amount. With this would have a smaller density than this one. They can actually get more in the same space, and that's really all density is grams. How many grams per mil or centimetre cubed? So a mil is a centimetre cubed. So how much can we actually pack in? Now that's going to be important, so that's why I thought I'd just mention that, because let's move these out of the way. Because we're going to need to convert density into mass. Because we will measure these in mils. Now I wouldn't mix these two together if they were mils, because we've got hydrogen bonding. Now if you've not covered hydrogen bonding yet, don't worry too much about it. It just means that when you mix two things together which are hydrogen bonded, so ethanol is hydrogen bonded with itself, water, as you probably know, is hydrogen bonded. You mix them two together, the actual density will change. So the volume that the individual, say ethanol would occupy, and the volume that water would occupy, don't necessarily equate when you add the both together. So 1 mil of ethanol and 1 mil of water, if you mix them together, wouldn't give you 2 mils. It'd just be slightly slightly lower or higher depending on how the hydrogen bond is affected. Anyway, that's a little digression. So we use density to convert the volume into grams. So if we take 10 mils, I'm just going to take 10 mils, I'm going to try and do it quite systematically. So we convert 10 mils using that figure there, and that means in 10 mils of ethanol there is 7.89 grams. Okay, so I'll just get my brush and I'll tell you what I've done there. So we've convert volume to mass. That's the first stage. We'll convert volume to mass, and the equation for that is mass equals volume times density. Okay, so we knew the volume was 10 mils, and all we need to do is convert the density, convert the volume to mass using the density. So the volume is 10 mils times 0.789 grams per mil. This is a known value which you can look up, and that should give you how much that should actually weigh if you weighed out 10 mils of ethanol. Why is that important? Well, because we know what the molar mass is, so we can now work out how many moles, that means how many molecules really, times Avogadro's number, to give us something we can actually work out in our heads or on a calculator or something like that. And if we do that, if we multiply then to get how many moles of ethanol we've got, this is the next stage here, we find that we've got 0.171 moles. Alright, so the next stage, I'll just re-emphasize what we've done here. So what we've done is we convert the mass into moles. Okay, mass to moles. Okay, so we've converted the mass that we calculated from the density from the mils to moles. That tells us how many molecules of ethanol are present. So remember, the moles is a number which you multiply by Avogadro's constant. So a mole of compound would be 1 mole of ethanol would if you weighed it out would be 46.07 grams. Okay, so that many molecules of ethanol would weigh that much. We don't have that many molecules of ethanol, we've got a fraction of that. See, we've got 7.89 grams, not 46.07 grams. So we need to know how many molecules are there, and it works out as 0.171. Okay, so that's like a fraction of what the real mole is. So how did I convert mass to moles? Because I seem to have skipped over that one. You convert mass to moles because mass, it can easily be converted like this. Moles, how many moles you've got, equals mass over the molar mass, or RMM, or formula weight or something. So this is an abbreviation that changes from school to school, year to year. So it's this value, it's the molar mass, and I put relative molar mass there. That's what the RMM stands for, relative molar mass. So that can sometimes be called, so that's RMM, or it can be called FW. I've seen that in laboratory notebooks. FW is formula weight and things like that. You might see other things, but basically it's the molar mass you want. So basically you take how many grams we've got, we've worked it out, 7.89 grams, divided by the molar mass, or relative molar mass as I've written it. So 7.89 divided by 46.07, 7.89 divided by 46.07 gives us how many moles we've got. So we know that in 10 mils of ethanol, we have got 0.171 moles, And if we wanted to, we could actually work out how many molecules of ethanol are present. Simply multiply that by Avogadro's number. But that would be quite a large number to deal with. So the moles is actually a fantastic way of dealing with this. So let's just talk about moles for now on. So that's the first stage. We work out how many moles we've got. We do the same again for how many moles are in 10 mils of acetic acid. Okay, so I'll very quickly go through that now because the process is there. And I'll reiterate that later on as well. The process is there. So basically change mils to mass. From mass you work out how many moles. Okay, I'll keep that and I'll put that back up at the end because that can be quite important, I think. Shrink it down a little bit, move it out of the way. Just in case you are wondering what Avogadro's number is, I do have it around here somewhere. Here we are. So it's 6.02 for sake of argument times 10 to the 23. It's quite a large number. Okay, so it's quite large. It's not something we want to be dealing with in everyday life. So we've got ethanol, we've got 0.171 moles. Now what I'm going to do now is I'm just going to move these out of the way to there and put the same thing up for acetic acid. So this is what I got earlier. So I would like to have put that under there, but so what I'll do, I'll just write acetic acid here in blue. Use a nice colour of blue. So that's acetic acid. Okay, that's this. The density of acetic acid, which you can look up, is 1.049 grams per mole, so it's a lot different to ethanol. The molar mass of acetic acid is slightly bigger than ethanol. It's 60.05 grams per mole. Now in 10 mils, I've calculated that 10 mils of acetic acid multiplied by the density should mean there is 10.49 grams in 10 mils of acetic acid, which is good. So using the same principles I did before, from that mass, so this is mass, I then calculated how many moles. Now moles are given by, let me just drag some text down and put it over here. I'll change that to red text. Okay, moles equals mass divided by the molar mass. So the moles, how many moles of acetic acid do we have in 10.49 grams? We have 0.175 moles. Now that's different to this. Now that's important as well. We see that 10 mils of acetic acid has slightly more molecules than 10 mils of ethanol. Now this is a real case situation here. We've not rigged the maths to suit our calculations. We literally took 10 mils of ethanol and reacted it with 10 mils of acetic acid. But we've got these strange numbers. So how much of ethyl acetate should we expect? Well, once this is all consumed, once 0.171 moles of ethanol is consumed, there's not going to be any more ethanol to make ethyl acetate. So that means there'll be a little bit of acetic acid left over in this reaction because of 10 mils. And we know this because we know that there's 0.171 moles of ethanol, but there's more acetic acid. Okay, so before we even do this reaction, on paper we've calculated there should be, and I will just write the excess down, there should be 0.004 moles extra. Okay, and that's because we've got a slight excess of acetic acid. We want to do this properly in the laboratory, then we would probably use 0.171 moles of acetic acid and work backwards to find out how many mils to add. Okay, that's what we would do. But in this case, we've just got 10 mils reacting with 10 mils. So there's going to be a slight, so I'm actually going to put that up here now. There's going to be a bit of acetic acid. And you notice I keep using AC here, but I won't do that. That's just AC is actually an abbreviation for this part of the molecule here called the acetyl group. But that will be confusing, so I won't actually write AC there. I will draw acetic acid. Alright, so we know that's going to be one of the byproducts. It's going to be carried over from there, and that's 0.004 moles. If, and only if, we have 100% yield. Anything that doesn't react will be carried over. So that's best case scenario. That's when everything reacts. We'll have an excess. We'll always have an excess because we've not got these right at the beginning. Okay, so where are we? We've worked out the mass. We've worked out from the mass the number of moles. We now know there's a slight excess of that number of moles. That's fine, we can live with that. How many moles should we expect when these react together to give 100% yield? So this tutorial will just deal with the 100% yield. If these two react, we should get, now this is when we have to start working backwards, we should get 0.171 moles of ethyl acetate. How do I know this? Well, I've just explained that once all that's consumed, there won't be any more reactions to form that. So we should get 0.17 moles of ethyl acetate. If all these molecules react, then they should all be incorporated here. And this is a new molecule, so it should have the same number of molecules as product as you added the starting material. So that should become 0.171 moles. Alright, and look at this diagram here. Basically all I've done there is, if we started off with 0.171 of these, and that reacts with that, and that red bit there is that red bit there, then we should have the same number here as we started here. Okay, so we should end up, our theoretical yield will be 0.171 moles. So what does that weigh, and how many mils does that occupy in a measuring cylinder? Well, let's calculate that. I'll just make these a bit smaller so we've got some room to play with. Okay, I'll recap all this in a second. Let's move that over there. Let's move that back out of the way actually. Okay, so we need to now work out the mass and the volume this will occupy. So we've got 0.71 moles, we need to work backwards. So 0.71 moles of ethyl acetate should be how many grams? So we need to know the molar mass of ethyl acetate. I've got that here. So this is going to help us. For ethyl acetate, we're looking at this now. The molar mass of ethyl acetate is 88.12 grams. Okay, 88.12 grams. We have 0.171 moles. We need to do this calculation. We need to I'm just getting my brush. We've got moles equals mass over RMM, that's a capital. So 0.171, so working backwards, 0.171 equals mass, we don't know, so I'll call that X because I don't know that one, over RMM over 88.12. That was going to be in grams, and this is in grams per mole, and this here is in moles. Now what I need to do now is multiply both sides by 88.12, and in doing that, this, if I just make an arrow here, This equation then goes to 0.171 multiplied by 88.12 equals x. Okay, that'll be our mass. Now in terms of units, that was in moles. This one here is in moles per gram, and this is in grams. Sorry, that one is in grams per mole. I should know better than that. So that is in grams per mole equals grams. So very quickly we can see that moles is going to times grams per mole, should cancel them out like that, leaving us grams. So that one and that one go. Grams equals grams. Everything looks good. All we need to do now is multiply 88.12 by 0.171. So let's get a calculator up. Here's a calculator. And we have 0.171 times 88.12 equals 15.06. So I'll move that out to the side. Get this back again. So x equals 15.06 grams. Okay, so that equals 15.06 grams of ethyl acetate for 100% yield. So that's 100% yield. Okay, so now we've got the grams. If I just tidy this up a little bit, move this out of the way, put that down there, delete that. Okay, so we worked out from the moles, from the molar mass, from how many moles we should have in a theoretical yield of 100%. Okay, that's very important. This is theoretical. We're trying to work out what we really should get in total. We should have 15.06 grams for a good reaction. Now what does that mean in terms of volume? Well, that's when we need to work out how many, we need the density, so we need to work out how much volume 15.06 grams occupies. So let's do that now. So we have mass equals volume times density. We have the mass, so that's 15.06 grams equals volume. We don't know that. Let's leave that as V for now because we don't know that. So equals volume times density. We've got the density there is 0.897, 0.897, and that's grams per mil. Grams per mil. Let's see if I can squeeze over. And I'll just get rid of that line. Okay, so that's mils there. This could be centimeters cubed, so mils are centimeter cubed. I'll just write that on as well because that's quite important. So sometimes you see centimeters cubed. Okay, right, so we need to now divide both sides by the density in order to leave the volume on this side. So that the next step in that calculation is 15.06 grams divided by the density, which is 0.897 grams per mil, will give us the volume, and the units of that is mils again. Now let's have a look at the units before we go any further. We look at units, we've got grams divided by grams, that gets cancelled out. And because this is the reciprocal, or the 1 over mils, that actually goes up to the top and it becomes mils. So all the units are fine there. all we need to do really is calculate what 15.06 divided by 0.97 is. So let's get the calculator again. Let's get that up. We've got our figure already in there, so we just need to divide that by 0.897. So divided by 0.897, and there we are. Now you notice there's a lot of decimal places there. Now we only went to 3 decimal places here and 2 decimal places here, and I will cover a tutorial on which decimal place is important. For this tutorial we'll just go to the second decimal place, so we'll just go to the 7-9 bit. So we need to look at this number and we need to multiply that up because it's next to an 8, so that will carry that one over. So we're going to write for this answer, if we try to measure this out as well, it would be 16.8. So we'll leave that as 16.8. Okay, so that's going to be our volume. Let's move that over there. So the volume that we've calculated is 16.8 mils equals the volume. I'll just try and tidy that up. So just as a recap, because this is the end of the tutorial now on reaction yields, if we take 10 mils of ethanol, react it with 10 mils of ethyl acetate, we should get 16.8 mils of ethyl acetate. So all those who probably thought we'd get 20 mils can see that by doing the calculation on how many molecules we're really reacting, we can see how many molecules of that we get, and based on the density and the mass and things like that, we have to work out it's 16.8 mils. And we can actually work out how much excess of the starting material, so these are both starting materials, we'll have anyway, because there wasn't enough ethanol to start with. So I hope this is introduce you to a very real situation where you wouldn't be dealing with ideal numbers. This is actually a made up on the spur of the moment reaction, and we took 10 mils and 10 mils, and we didn't get quite 20 mils and things like that. The key message to working out yields, I hope I've emphasized that. First of all, we convert any volumes to mass, and then, in fact, let's recap that in the text. Actually, let's just give ourselves a little bit of room here. Let's move these out of the way. So the first thing to do, if I write this down, the first thing to do, give myself a thinner pen, is convert volume to mass. Okay, so convert volume to mass, that's the first step, that's number 1. And then I just put ditto there for that. Convert mass to moles. That's step number 2. Okay, so we converted the volume to the mass, and then we worked out how many moles that mass meant. So we used the equations we used here. If I use a green pen, that was mass equals volume times density, and this one was moles equals mass over RMM. Alright, once we've got the number of moles, we know actually how many molecules or atoms or whatever we're dealing with is actually there, and obviously we need to work out how much is there of each individual thing, and from that we should be able to work out whether we've got enough or whether we've not got enough, and from that we can work out what we should expect, and that's what we've done there. So that's the end of the tutorial. I will do another tutorial on working out actual percentage yields based on actually not getting 16.8 mils, for example. I'll use this as an example. I'll use this calculation that we've just done as an example as well, but we'll look at what it means if we get 8 mils or something like that. Okay, so that's it for now. Bye bye.